Just to repeat, question 7 from the previous part. By varying the temperature, would it be possible to change the spontaneity of the reaction from question 5? Remember, it was not spontaneous because change in G was positive, but you would be able to change the spontaneity because then if the temperature was, say, higher, then T times the change in S would be greater than the change in H, therefore making the change in G negative, therefore making the reaction spontaneous. The equation we use, of course, is change in G is equal to change in H minus the change in, or T times the change in S. Number 8, the overall final balanced equation for a reaction is 2 iron oxide plus 6 carbon monoxide goes to 4 iron plus 6 carbon dioxide with a change in G that is equal to negative 56 kilojoules. Why would O2 be left out of this equation if you started with it in the beginning? Basically, O2 appears on both sides of the equation, showing it's produced and then used up as well. So basically, it's unnecessary to write in the overall reaction because it'll just cancel out anyway. Number 9, consider the following reaction. Aluminum oxide is plus 2 iron goes to iron oxide plus 2 aluminum. Which of the following 2 reactions would prove beneficial when coupled with the above reaction? A, would it be methane plus 2 oxygen goes to carbon dioxide plus 2 waters? Or would it be B, 2 methanol plus 3 oxygen goes to carbon dioxide plus 4 waters? So basically, if we go to this slide, we're calculating the change in G for the aluminum reaction. So basically, you want to use the info on the table of standard values that I had provided you with at the beginning of the tutorial. So basically, the initial aluminum reaction, the change in G was 838 kilojoules. Now to find which reaction we have to find which reaction has a change in G that is greater than negative 838 kilojoules. So basically, we use the standard values, and remember, products minus reactants. So the summation of the products minus the summation of the reactants for A is negative 800.8 kilojoules, which is not greater than negative 838. And for B, we get a change in G that is negative 1,404.9 kilojoules. Therefore, reaction B should be coupled with the initial aluminum reaction because it makes the overall reaction spontaneous with a negative G. For question 10, given your answer to question 9, write the overall equation after coupling, of course, of the aluminum reaction and the methanol reaction, and calculate the change in G for this overall reaction. So now you're just combining them. That's all you're doing. Now you have, for the change in G of the reaction, you have the 838 that you got from the initial aluminum reaction, plus the 1400 that you got from the methanol reaction. You add them together. Basically, you get the negative 566.9 kilojoules, which makes that reaction spontaneous. Now on to skills practice. I'll assume that you received this in your packet as well. The first question asks, given the following reaction, calculate change in H and change in S. So it's methanol reaction. 2 methanol plus 3 oxygen goes to 2 carbon dioxide plus 4 water. And now we look at our table of standard values for change in H. Remember, I can't stress this enough, products minus reactants. If you have coefficients, you multiply the values by those coefficients. And essentially, for change in H, you get